Welcome to episode 8 of the Amazing Refactor. In this episode, firstly, we're going to correct something that I missed in episode 7. So we're going to rewind a little bit and go over some of the elements of the last refactor in order to call out some elements where I've done something more than just abstracting functions. Then we're going to follow on from the end of that video and complete the rest of the refactor. The first part I wanted to revisit was part of the refactor where I looked at all these rand functions. This piece of code is repeated multiple times with only a variation of 2 or 3 in most cases. It made sense to me to pull that out into a function, but ReSharper doesn't automatically detect that kind of reuse of code in the same way as the IntelliJ Java environment does, also written by JetBrains. Why? I don't know. But this meant I had to go through and manually change all the instances of random.rand2 and random.rand3 manually to the function I'd just extracted. Tedious, but a necessity. The main aim of this is to encapsulate the fact that we're doing the change of type, so we're casting it to an int when it gets the return value, and making the code read a little better by explicitly saying random of 3, random of 2. There is one function here which is the rand of 0 times 2 plus 1, which is using some slightly different logic, and maybe come back to look at that later on. The second thing that I thought was worth calling out separately, which I didn't cover in the previous video, was the separation of all the actions out of this one big if statements with switch statements block, because that is definitely doing more than one thing. Now if you watch very carefully here as I start extracting this function, you'll notice that I managed to do something to remove it before I'd even done the refactor. I have no idea, and I didn't notice at the time. This, coincidentally, is actually what caused the unit tests to fail later on. So the aim is to pull all these switch statements out into individual functions that give us something that looks a little bit cleaner. Because I've done one there, I'll speed up the rest until we get to the next stage. Now we can go through all these and change them to a switch expression and remove the comments as we go. And now we've done that, we can look at extracting them into their own class. This is exactly the same as you've seen me do in the previous video, so we'll speed it up. The last thing I wanted to call out from the previous video that I didn't was the work I did to change all these if statements into question mark notation, and I extracted some of them out into their own functions at this point. This concludes the things I'd like to call out and brings us on to the next part of the refactor, continuing on from this point. So continuing on from the work in the previous video and what we've just covered, the next thing to actually look at is pulling out all these now question mark notation if statements into their own functions and then working out where those actually live. What we've essentially done is split down that big if statement with nested if statements into a binary tree of several different functions. In addition to that, we've also rationalized a lot of the logic down into individual functions, making the code easier to read. Because some of that refactoring has put things all over the place, I'm going to move all the functions that are logical, i.e. the ones returning a bool, the extraction of our logic for the if statements, down to the bottom meaning that everything to do with movement is actually at the top. I'm then going to go down and check all the isolation levels on all the functions to make sure those are correct and we're not exposing anything we shouldn't be.
As you'll have noticed at this point, I've just realised there is actually something adrift with the right and down functions. It appears that right and down at some point have been switched. That's very obvious when you consider the function name of move right or exit maze. You can only exit a maze by going down, not right.
So now we've got to the point where everything is in its own class. However, things aren't necessarily in the right projects. To address that, we're going to create a new project and shuffle all the things that are to do with the core of our maze creation into that one project. So the next thing we're going to do is, now we've got a nice shiny new project, we're going to put some of these classes into it. So the only thing we need in the Amazing, the original command line program, is the program CS. Everything else can move into the core. There are functions that allow you to refactor this inside ReSharper, but for whatever reason I don't tend to use them. So I've literally just cut and pasted all those class files into the new project. We can now shuffle some of these class files around, making sure they're organized nicely within the library. So while we're doing that bit of reorganization, we also need to resolve all the things we need to reference and sort out the namespaces, because we've shifted all these classes into a completely new project which has a different namespace and doesn't actually pull in everything that we need. This also gives us the opportunity to get rid of some of the things that aren't needed as far as imports go and only have the NuGet packages we're actually using. Because this is quite tedious and not that interesting as such, I'm going to speed this up from this point on until we get to something a little more interesting. I've got most of this sorted out. We can actually make these into nice functional pipelines. I prefer to have each of the elements of that pipeline on a separate line because I feel that's more readable. Many won't agree, and some people think I refactor down far too far. But that's each to their own. I've also statically imported the duck class. Again, that's also just a personal preference because I think it makes all these merge commands look a little bit tidier. Now for something slightly more interesting. If you remember, quite a while ago we duplicated a piece of code, and that was because we had a function to set a wall on the right hand side and a function to set it on the top. There is actually a large quantity of duplication. The only difference being we're setting a wall to the right as opposed to a wall at the top. This means we can break that out into a single function that augments a wall, and we can pass in the element that we actually want to change. So whether that's wall to the right or a wall to the top. And to make this more readable, instead of just having 1 and 2 passed into the function, we're actually going to make a constant that actually describes what that actually means in terms of a wall to the right or a wall to the top. So that's nicely removed the duplication and has made the code a little bit more readable. Now we've done that, we can tackle this much larger function and break that down into separate parts and make that a little bit more readable and make sure we're only doing one thing in each. This should result in a nice functional pipeline as we saw earlier on. So that's broken down that big function into quite a few small, concise functions. Now this is an example of if you run the unit tests after doing quite a lot of refactor, Visual Studio doesn't actually realise you actually need to rebuild everything. So what looked like quite a catastrophic problem is in fact just it hadn't rebuilt everything. All the tests do still pass and we haven't actually broken anything. Now we've actually completed the lion's share of the refactor and we know all the tests still pass. For curiosity, I'm just going to have a quick look at what our code coverage looks like now we've completed most of the refactoring. As you can see from this, the bits that aren't covered by unit tests are just the interface, which are user stuff. The best way to test that is in fact by running it. But we've got 100% coverage on that amazing core, which is actually far, far more coverage than we had before we did the refactor. So now the bits of code we haven't touched are in fact the bits that are doing the drawing of the maze and the bits that are asking you the questions about how big you want the maze to be, i.e. all those UI functions. So it makes sense that we should do a similar kind of refactor to those as we've done to the rest of the code. However, these parts of the code are not covered by unit tests, so that means we're going to have to test it manually. This part of the refactor doesn't really cover anything new conceptually. However, it does highlight that testing things manually occasionally goes a little bit awry and finding illogical errors a little bit harder. I'm going to speed this up from this point on because there's an awful lot of mucking about trying to get this working because I made a bit of a mess of it. So I've split down those functions pretty much in the same way as you've seen me do quite a few times before. But as you can see by running the maze application now, I've done something catastrophically bad to how this is now outputting the maze. This is going to take a little bit of fettling to find out what on earth I've done wrong. Genuinely is the solution when something's gone this badly wrong? Well, we know the unit tests pass, and we know this used to draw a maze, so maybe we just keep pressing Ctrl Z until everything's back to how it was when we started, and try again. So now we've asserted that this is back functional. Because we've undone everything we'd already done, we can start refactoring it again, hopefully this time with a little bit more success. As you can see, our refactor this time went much better than our first attempt. This pretty much concludes the entirety of the refactor. There isn't much I can do to these functions for the asking you questions about what size maze you want and the output elements that are specific to the console implementation. We're just going to make sure that everything still builds and absolutely make sure all the unit tests still pass. There is just one tiny last thing we need to do, and that's remove the entrance from the iMazeState interface. We no longer use it and we have no use for it. Everything's saved. All the unit tests still pass, and our code coverage still looks pretty good.
Well, that concludes the series so far of our Amazing Refactor. We've got to the end of it, it still works, and we've got a much cleaner code base that's a little more in line with what we'd expect from coding today versus where we started, with 138 lines of basic code littered with go-to statements. But is this the end for this little project? Well, I'll leave that up to you. If you think we should continue and do something with this, that might be as strange as porting it onto a Raspberry Pi, making it run on something else. Building an output that's to something more modern, making it graphical. Please put your suggestions in the comments, and then we'll pick this up once we've got a consensus of whether we should do or not.